So Ivan, you mentioned that there's a lot of little things that go into building a new meter, things that may not be obvious to the casual observer. Do you want to give us some examples of that?
So we have an outer cover. So that outer cover pulls off in field. And under that, we have this area here, which gives us our expandability. So we've got a built-in modem here, so we can get connectivity straight off the bat. But there's also the option with the pod to go, okay, I need a new modem. I need some new technology of connection. I need an edge intelligence or something like that I can add in and put that in the field. And I can do that while the product is still supplying power to the house and it still remains safe. I've got this inner cover, which then gives the protection of my live terminals. So this means that I can route my cables separately. Down here we've got separate spaces even to route cables away from the rest, but my live cables are still protected effectively. These ports, they're high-speed ports, so that gives us a lot of options in terms of what we connect here. So it's more than just a simple on-off connection or serial port. We can actually stream the full waveform data through that. High speed, even up to the 3-phase, and that lets us add on edge intelligence for additional processing beyond what maybe we can do in the meter today. Not that we can't do a lot on the meter, there's a lot of headroom there, but just there's always one thing more that someone wants, and we want the ability to enable that now or in the future. So this asset on the wall, it gives you that 10, 15, 20-year life in the field.
I see this one looks like it's got some I/O that's connected. Also, maybe a 485 port or an Ethernet port. Do you want to explain what that's an example pod?
This one's a 485 and a couple of traditional pulsed I/O.
Yep.
So this can let you hook into your building, typical 485 building management system, or connect to a BMS system. Now looking at going, okay, we can get an Ethernet there. We can have RS-232 if you want different communication solutions, different amounts of I/O. All of it is quite expandable. And the pods are the same pods across the whole family. So we've got some ability in the 3-phase where we can have larger pods of 3-phase only, but typically you may want a bit more connectivity.
And Tomo, how does this play into the whole solution problem?
Yes, I think we've tried to step up and out and go, what do we need at a solution level? And you know, as Ivan's pointed out, what this has enabled is a few different things. The first one is it enables us to then add something onto the meter at some point later to balance that potential upfront cost with a lifespan of 20 years, to allow that, you know, retrospective add of extra compute, but at a speed between the meter and that compute that allows a waveform to go between those two devices, so that you can do something with the measurement of what you're doing on site, which is significantly better than maybe, you know, some of the competitor solutions in the market, where they've got a really cheap meter that does, you know, core measurement and does that reasonably well, but there's no ability to expand or, you know, enable more calculation on the edge, because the data that you're sending between that device and your edge compute is just way, way smaller. So I think this opens up a truckload of different possibilities in the solution long term. Everything from, as we said, adding an edge intelligence to, you know, you could see a world where ubiquitous communications is low cost, and you could be, you know, sending waveforms back into some cloud, you know, in 15 or 20 years time, because that's where technology has evolved to.